All right, let's talk about composition functions. So we have f of x equals 2 over x plus 1, g of x equals x over x minus 3, and we are asked to find f composed of g of x and its domain. So let's talk about what that notation means. So this f composed of g of x, that notation means f of g of x, just like this. So I'm going to replace that g of x that we've got. So this will turn into f of x over x minus 3. All right, so what that's talking about next is you're going to take everything that you see inside these parentheses, and you are going to replace the x inside of my function I've called f of x. So that's what that notation there means. So let's see what we can get with that. This is going to become a 2 over. Now again, that x is going to be completely replaced with the x over x minus 3. And I still have the plus 1. This is that composition function. Now, of course, we're going to simplify this and then find its domain. So let's talk about simplifying this for a second. We need to get rid of all these fractions. Best way to do that is you'll notice that denominator of x minus 3. If we multiply top and bottom of the big fraction by x minus 3, most of the fractions will go away. So let me show you what I mean by that. I'm going to put an x minus 3 here. This positive 1 right here is going to get an x minus 3. And then, of course, the other side also has to get an x minus 3. So I did a couple of different things there. Talked about the top half and the bottom half. Those are the two halves that each got the x minus 3. Now, on the bottom, both of these had to get the x minus 3 because there was distributing across the plus sign. All right, so that's what we're talking about. The reason we did that, of course, is this is significantly easier to deal with the fraction. So on top, I ended up with a 2, x minus 3. Notice that x minus 3 cancels here on the bottom left. And I'm left over with an x and then plus the 1 times x minus 3. Okay, let's continue to simplify that. So I'm going to rewrite that what I've got over here. 2 times x minus 3 all over x plus x minus 3. And then we're going to simplify. On top, I can distribute the 2 across the parentheses. On bottom, I can combine like terms. I end up with 2x minus 6 over 2x minus 3. And that is our simplified composition function. Okay, this is f composed of g. All right, of course, those two x's don't cancel because they only can cancel if it's multiplied, but I've got a minus on both top and bottom. All right, so that's the composition. Now we need to talk about the domain. Okay, so let's start talking about a couple of things about the domain. So we're trying to find the domain of f composed of g of x. Best way to start this is to start with the inside. So let's talk about the domain of g of x. Okay. Going back, remembering what g of x actually was, we have g of x to be x over x minus 3. The domain is going to have to be things that you're allowed to plug in that don't give you 0 on the bottom or square roots of negative. In this case, if I plugged in 3, that would give me 0 on the bottom. So that means my domain of g is x cannot be 3. Let's talk about the same thing for f, just so we can have a combination of these guys first before we start trying to combine them some way. So the domain of f, you look back at that function and notice if I plugged in negative 1, that would give me 0 on the bottom. So that domain would be x cannot equal negative 1. All right, once you have the domain of the inside and the domain of the outside, you have to think about what this composition is. Okay, so this composition is taking g of x and plugging it into f of x, okay, which means my g of x is what has to not equal to this domain issue for the function f of x. Okay, all right, so that's what we've got there. Let's talk about what that means now. So g of x cannot equal negative 1. Actually, I'm going to go back and try to use the same colors here. G of x cannot equal negative 1. All right, so what is g of x? G of x is x over x minus 3. So this is what cannot be negative 1. Notice it's my inside. That cannot be the domain issue for my outside. And then, of course, we can go ahead and solve this just like any other equal sign. I'm going to make this over 1, cross multiply. No different, as if that equal sign is just like every other algebra problem. X times 1 is going to give me x. Then I'm going to have negative 1 times x minus 3. distribute, add x to both sides, and then divide by 2. Okay. Now, of course, this started off with a cannot equal, so all of these are cannot equal. So I end up with x cannot equal 3/2. That's what finishes the domain for us. So now I've got the domain of f composed of g, okay, is, now we know we've got x cannot equal 3/2. But you also have to include the issue for the inside function. So go back and look at your domain of g. This has to be included, whatever my inside function was. X can also not equal 3. So x cannot equal 3. So that's my domain. Now let's write that in an interval notation. Let's rewrite this over here. So the domain of f composed of g, we've got x cannot equal 3 and x cannot equal -1. If we wanted to write that in interval notation, this would be -infinity to -1, not including -1, union -1 to 3. Oh, it wasn't -1. I apologize. What was it we had before? Here we go. It was 3/2. Right here, I apologize. Definitely should have stayed as a 3/2. 3/2. All right, let's try that again. Okay, interval notation. Interval notation here is going to be then the -infinity to 3/2 union 3/2 to 3 union the 3 to infinity. Okay, that's going to be my domain of f composed of g. Again, let's clarify this one more time. All right, we had to keep when we had g of x cannot equal to the domain for the outside, what we got when we solved that was 3/2. That has to be a part of our domain issue. And then always you go back and talk about the domain of the inside, and that was the 3. The -1 isn't necessarily part of the domain in your final composition. Okay. Ta-da!